In this video, we'll demonstrate how to perform the CT excitation curve test using the ALLINA T1. The nonlinear characteristic of the core can be represented in two ways. Magnetization characteristic, expressed as the RMS value of the no-load current and the per unit RMS voltage applied to the secondary winding. Hysteresis characteristic, represented by the instantaneous flux turn values in relation to the no-load current, in the saturated state of the CT. Specifically, the hysteresis characteristic refers to the major loop. ALLINA device, both the magnetization curve, essential for matching nameplate specifications, and the major loop of the hysteresis curve, critical for CT diagnostics. To begin the test, connect the device to a power source, turn it on, and input the CT information into the manager section. Once the data is entered, proceed with configuring the test settings. For the CT saturation curve test, navigate to the current transformer test menu and select the excitation test option. Next, choose the desired testing standard from the standard menu. For example, according to IEC standard, the knee point of saturation is defined as the point where a 10% increase in applied voltage results in a 50% increase in no-load current. Select the core, phase, and tap under test from their respective fields. When setting the applied voltage limit using the Vmax option, ensure that it is higher than the CT's knee point voltage. If the knee point voltage is lower than the Vmax you set, the device will increase the test voltage up to 1.2 times the knee point voltage before stopping. However, if the Vmax is less than the CT's knee point voltage, the device will limit the test voltage to Vmax and prompt you to increase this value. For the Imax or maximum injection current into the secondary winding, it is recommended not to exceed the rated current of the tap under test. If you're unsure of appropriate values for Vmax and Imax, you can use the automatic estimator. This feature calculates and populates suitable values based on the CT's nameplate information. You can also set the test voltage frequency via the frequency option. The default value is 50 Hz, which corresponds to the network's nominal frequency. While it's possible to perform the test at a lower frequency, IEC 61869 standard recommend testing at the nominal frequency. To compensate for the effect of the winding's ohmic resistance in the core saturation curve, there are two methods. The first method involves measuring the DC resistance of the secondary winding beforehand and then entering that value in this test so that the device accounts for it in its calculations. The second method is applicable when the CT is equipped with a tap through which current does not flow during this test. In this case, the specified tap should simply be connected to the 300 volts peak input of measurement 1. The turns ratio for that tap will be automatically measured during the test, and there is no need to enter it in the software. Wiring diagram for the selected configuration can be viewed in the software, offering clear guidance for proper connections. During the test, disconnect any burden from the CT secondary and connect the CT secondary winding to the device's 2200 volts AC output. By injecting voltage into the secondary and measuring the resulting current, the device determines the knee point voltage and generates the hysteresis curve. This method supports CTs with knee point voltages ranging from 5 to 2200 volts. Once the test settings are complete, click Run to start the test. The measured values will be displayed in real time, and the magnetization curve will gradually build up. At the end of the test, the results will include the tested phase, core, and tap, along with the frequency of the applied voltage. The output will also show the magnetization curve, the major loop of the hysteresis curve, the knee point voltage, and the corresponding magnetizing current. A table of the applied voltages and measured currents at different steps is provided, highlighting the knee point voltage and current. Here are two important tips. 1. During this test, the device automatically demagnetizes the CT core before determining the knee point voltage and hysteresis curve. Once the test is complete, no residual flux remains in the core. Because residual flux can affect the ratio test results, it is recommended to perform this test before the ratio test and after the winding resistance test. 2. If the CT does not reach saturation during the test, increasing the maximum voltage and current settings should resolve the issue. However, improper test wiring could also be a cause. It is essential to check the wiring connections to ensure proper functionality,